Hello students, welcome to my channel. Today I will discuss about the structure and hybridization of different molecules. Here some molecules and ions are mentioned and you have to predict this hybridization structure in a few seconds. So let's start. Firstly, BF3 boron trifluoride. Here you see that the last valence electron, that is the last cell electron of boron, is 3. So these 3 electrons combine with 3 fluorine atoms. So these 3 sigma bond are formed. This fluorine and this. So the number of sigma bonds 1, 2, 3. 3 sigma bonds. You have already know about the definition of hybridization, and in hybridization, sigma bond and lone pair of electrons take part in hybridization. So here bond pair equals to 3. So hybridization also 3, that is sp2. One is s orbital and 2 is p orbital, that is sp2, 3 bond. The bond angle is 120 degree. Understand? If you want to find the hybridization with formula, you can use this formula, half V plus X minus C plus A. This is the valence electron number. This is the number of monovalent atom. This is the cation and anion. Here the valence electron number of boron is 3. The monovalent atom, that is 3. Cation and anion 0. So 6, that is 3, that is sp2. Since this structure is sp2, so this is planar structure. This is planar. Okay. Next is SO2. Here the valence electron of sulfur is 6 and it attached to the 2 oxygen atom. So the probable structure we have already know this. This is the angular structure due to the repulsion of lone pair and bond pair, between lone pair and bond pair. Here you have to know the hybridization in shortcut. That is 1 lone pair, 1 sigma bond and 1 coordinate covalent bond. So that is angular structure, and here the hybridization equals to 1, 2, 3, that is 3, that is sp2. Okay. Now ICl2 minus. Here iodine is attached to chlorine atom and 1 minus charge on the iodine atom. Minus charge means 1 extra electron. So the valence electron of iodine is 7 plus 1, that is 8, and attached to the 2 chlorine atom. So this between 8 electrons, the 2 electrons bond pair with chlorine, that is 6 electrons left, and 6 electron means 3 lone pair. So 2 bond pair and 3 lone pair, and the structure will be like this. Here the total number of valence electron of iodine, that is here 1, 2, 3, 4, 5, 6, 7, 8 with 1 minus charge. Here you have to find the hybridization without formula. See the picture. Here lone pair, number of lone pairs 1, 2, 3 and number of sigma bond is 2, that is 5. 5 means sp3d. Understand? If we put in formula, that is half V plus X minus C plus A, then you will find the valence electron of iodine is 7 and the monovalent atom chlorine, that is 2, minus cation, that is 0, plus anion, that is 1, minus charge, that is 1. So half into 10 equals to 5. 5 means sp3d. Clear? 2 sigma bonds and 3 lone pair. Next, ICl4 minus. Like ICl2 minus, here also iodine bears one negative charge, that is one extra electron. So the valence electron, that is 8, 7 and 1. And between 8 electrons, it can form 4 sigma bond with 4 chlorine atoms. So here bond pair equals to 4 and lone pair equals to, that is 4 chlorine atom attached, and the left electron will be 4. So 2 lone pair, that is 2. And the structure will be like this. Square planar structure here, and you have to find the hybridization without putting formula. Here number of sigma bonds, count the number of sigma bonds and number of lone pairs. Here the sigma bonds 1, 2, 3, 4 and lone pair 5, 6. So 6, the number is 6, that is sp3d2. Okay. So the hybridization of ICl4 minus in iodine, that is sp3d2. If we formulate this, that is V plus X minus C plus A. So half, and the valence number of electron is 7 plus monovalent 4 minus C, that is 0, and A, that is 1. So 6. 6 means sp3d2. And here the structure name is square planar and the hybridization of iodine is sp3d2. Okay. Next, XeF4, that is XeF4, xenon tetrafluoride. Okay. Here the last cell electron number of xenon is 8, and these 8 electrons, between 8 electrons, xenon combine with 4 fluorine atoms, sigma bond, and left electron is 4, that is number of lone pair equals to 2 and bond pair equals to 4. Bond pair equals to 4 means 4 electrons and lone pair equals to 2 means 2 to the 4 electrons, that is 8 electrons. So the structure will be like this, square planar, 4 fluorine atoms and 2 lone pair of electrons. Here the hybridization of XeF4 will be number of sigma bond 1, 2, 3, 4 and number of lone pairs 5, 6, that is 6. So 6, that is sp3d2. Okay, the hybridization of xenon here sp3d2. So the hybridization of xenon here sp3d2. Understand? If we formulate this, H equals to half, valence electron of xenon is 8 plus 4 fluorine atom, that is 6. Okay, 6 means sp3d2. 1 s, 3 p orbital and 2 d orbital electrons involved in hybridization, and that is sp3d2. SF4, next SF4. Here the valence electron of sulfur is 6. Between these 4 fluorine atom attached with these electrons, so bond pair equals to 4. Between 6 electrons, 4 electrons are attached with fluorine atom, so the lone pair electron number is 2, so the lone pair is 1. Lone pair equals to 1. First I predict the structure and then I will calculate the hybridization of this structure. Here the same plane, and that is the another plane, fluorine, 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 fluorine. Here number of sigma bonds and number of lone pairs can take part in hybridization, so you can calculate the hybridization in few seconds. 1, 2, 3, 4, 5. So that is 5. So the hybridization is sp3d. Clear? If we formulate H equals to half into valence electron is 6 plus number of monovalent, that is 4, 6 plus 4, that is 10 by 2, that is 5. So sp3d. Next, NH4 plus, that is NH4 plus. Here the nitrogen valence electron of nitrogen is 5 and it attached with 4 hydrogen atom, and the structure will be like this, tetrahedrally, with this lone pair attached with 1H plus, that is coordinate covalent bond, that is NH4 plus, tetrahedrally elongated. Here you have to find the hybridization of nitrogen. Calculate the number of sigma bonds, lone pair and coordinate covalent bond. Here there is no lone pair in this nitrogen atom. The number of sigma bonds 1, 2, 3 and 1 covalent bond, that is 3 plus 1 equals to 4. So the hybridization is sp3. Okay. If we formulate H equals to half into number of valence electron of nitrogen, that is 5, number of monovalent, that is 4, and 1 cation, that is plus charge, so minus 1, that is 4, 8, that is 4, sp3. Here with nitrogen atom 4 bonds 1, 2, 3, 4 are tetrahedrally elongated. So the structure is tetrahedral. Next, ClO4 minus. The valence electron number of Cl is 7. With this 4 oxygen atom attached with this. Since the electronegativity of oxygen is higher than chlorine, so the minus charge is of 1 oxygen atom, and the structure will be this 2 oxygen atom, and this is 1 oxygen atom and the another oxygen atom with 1 minus charge. Here the valence electron of chlorine is 7. So calculate the valence electron 1, 2, 3, 4, 5, 6, 7. Clear? Minus charge bears on 1 oxygen atom. Here you have to calculate the sigma bond, lone pair and coordinate covalent bond. Here the number of lone pairs of chlorine atom is 0. The number of sigma bond 1, 2, 3. Here 3 sigma bonds and 4 sigma bond is, number of sigma bond is 4. So 4, that is sp3. The hybridization of ClO4 minus, that is sp3. Now you have to formulate half valence electron is 7 plus, there is no monovalent atom, so 0. There is no cation, that is 0, and 1 anion, that is 1. 7, 1, 8 by 2, that is 4. 4 means sp3. Understand? And the structure is tetrahedral like methane. 1, 2, 3, 4. 4 sides elongated tetrahedrally. And the hybridization of chlorine is sp3. Okay. Number of sigma bonds 1, 2, 3, 4. 4 means sp3. Next, CO3 2 minus, carbonate ion, CO3 2 minus. Here carbon attached with 3 oxygen atom with 2 negative charge. This carbonate ion The valence electron number of carbon is 4, and with this 4 electron, carbon are attached with 3 oxygen atom. One oxygen atom is O negative, another oxygen atom is O negative, and another oxygen atom is double bonded O. Because carbon has 4 electron in valence shell, 1, 2, 3, 4, and 2 negative charge bears on 2 oxygen atom, this one. Okay, and the lone pair also. Here you have to find the hybridization of carbon. Since the number of lone pair of carbon is 0, so the structure is planar and trigonal planar. You have to calculate the hybridization in few seconds. First you have to calculate the sigma bond. Number 1, number 2, number 3. The number of sigma bonds, that is 3. Lone pair 0, no coordinate covalent bond, so 3, that is sp2. Clear? sp2. If we formulate H calculate, then the valence electron number is of carbon is 4, plus monovalent atom, that is 0, cation, that is 0, anion, that is 2. 4 to the 6 by 2 equals to 3, so sp2. Okay, clear? Next, NO2 minus, negative charge, that is this nitrogen atom attached with oxygen atom with one double bond, and another oxygen atom like this. Now calculate the lone pair. Valence electron number 5, here 1, 2, 3, 3 valence electron, so lone pair is, number of lone pair is 1, and number of electron lone pair, that is 2 electrons. So 1, 2, 3, 4, 5 electrons. Here number of sigma bonds 1, 2, and lone pair, that is 1, number of lone pairs, that is 1. So the hybridization, that is 3, that is sp2. Clear? Number of sigma bonds 1, 2, and lone pair, that is 1, so sp2. If you formulate this, number of valence electron of nitrogen is 5, monovalent, that is 0, cation, that is 0, plus anion, that is 1, so that is 3, that is sp2. Clear? And the structure is angular. Due to presence of this lone pair, the two sides bent, and the structure name is angular. Okay. Next, the last example here, Bf4 minus. In this Bf4 minus structure, boron attached with 4 fluorine atom, so clearly the number of bond pair equals to 4, and the last cell electron number of boron is 3. With this, one fluorine atom, one fluorine negative ion donate to the boron, so lone pair equals to 0, and the structure will be this F minus atom donate to the boron, and here 3 bond pair. Clearly the structure is like methane, tetrahedrally elongated, and this is a coordinate covalent bond, and this is overall minus. You can write this also, this. The hybridization, number of sigma bond 1, 2, 3, and one coordinate bond, that is 4. 4 means sp3. If you formulate H equals to half number of valence shell of boron, that is 3, plus number of monovalent, that is 4, cation, that is 0, anion, that is 1, that is 4. 4 means sp3. So the structure is also tetrahedral. Okay, understand? If you have any problem, then comment me. Okay, thank you.